So today we're going to be looking at radicals or roots and seeing how they fit with this exponent theme. So radicals and exponents, or I should say roots and exponents, are kind of like opposites. They're kind of like multiplication and division. So the opposite of rooting something is taking something to a power, and the opposite of taking something to a power is rooting it. So for example, the opposite of 2 squared is the square root of 2. The opposite of the square root of 4 is 4 squared. The opposite of 5 cubed is the cube root of 5, and of course the opposite of the cube root of 5 is also 5 cubed. So they have this sort of play of opposites with each other. And because of that, we can actually sort of combine them together. We can write our roots as exponents, and we can write our exponents as roots in some cases. So first, to demonstrate why this works, it's kind of like the way it works with multiplication and division. So for example, if I say 5 divided by 2, that is the same thing as saying 5 times a half. These are both the same problem. 5 divided by 2 is 2.5. 5 times a half is also 2.5 because they just both take half of 5. Same can be true for radicals and exponents. And again, when I say radical, it's just another way of saying root. So in this bottom one here, if I have the cube root of 5, instead of leaving it as the cube root of 5, I could write it as 5 to the 1/3 power. So roots just simply take the bottom portion of a fraction and use that as their exponent. So cube root would be 1/3, fourth root would be 1/4, 10th root would be 1/10, and in general it looks like this. The nth root of a number is equal to the number to the power of 1 over n. So the nth root is simply the number to the 1 over blank power. So fifth root, again, would be 1 over 5. Cube root would be 1 over 3, that sort of thing. And this is important because it allows us to use our rules for exponents for roots as well. Because now that we can write roots as exponents, we can use the multiplication, division, the power of power stuff. We can use that to kind of help us simplify roots as well as exponents in one go, rather than having them be two separate things we have to take care of. So, for example, if I have the 7th root of 3 to the 9th right here, if I have the 7th root of 3 to the 9th, instead of leaving it as that big mess, I could simply write it as 3 to the 9th, or rather to the 9th over 7. Because the 9th power sticks around and stays on top, and the root power is the one that goes on bottom, so they make a fraction. 9 on top, because that's the normal exponent, and then 7 on bottom because that's the root. Same can be true for when the exponent is on the outside. So in this case, the 4th root of 8 cubed, if I do it piece by piece, is really the 8 to the 1/4 to the 13th. Well, we should know what happens when I have two powers together. A power for power means I'm going to multiply these two things together. So it would give me 8 to the 13 over 4 power. So it doesn't matter whether the exponent's on the inside or the outside of the root, you can still just make it into a fraction. The normal exponent goes on top, the rooted power goes on the bottom of that exponential fraction. And you can also do this backwards as well, because sometimes we do want to split them up into roots and exponents to analyze some things. So if I have 12 to the 5/3, I can split that up and say that is 12 to the 5th, because the 5 is on top, cube rooted, because the 3 is on bottom, so that is the root power. So the bottom part of the fraction becomes the root portion, the top part of the fraction becomes the normal exponent. I could have also done the cube root of 12 to the 5th, so I could also switch the position of the 5 and the 3 and write, whoops, don't want to write a 13 because I am still working with 12. I could write cube root of 12 to the 5th power. That would also work. They both mean the same thing. And then another kind of side property of this is because this is the case, we know that if I have a root and I have the complementary power, they're just going to simply cancel each other out. Just like if I multiply 2 and then divide by 2, I've done nothing. Or if I've added 5 and then subtracted 5, I've done nothing. I've changed nothing. So if I take the fifth root and then take it to the fifth power, I've done nothing to the value. So explicitly, this would be 9 to the fifth over 5. But 5 over 5, again, anything divided by itself is 1. So this is just 9 to the 1, or just 9. So these two cancel each other out, and I'm just left with the inside number. So that is sort of the consequence, or in some cases the proof, that this root to rational stuff works, is because a root and a power that is the same will cancel each other out. And of course, we can do it when they don't cancel out either. We can actually even simplify it in some cases. So in this case, we have 9 to the fourth square rooted. Well, remember, square root is a 2 power. So this is kind of like an invisible 2 here, because it's the square root. There is no such thing as the 1th root, because the 1th root of anything is just itself. So it's the square root is the invisible 2 there. So this would be 9 to the 4 over 2. But I know what 4 over 2 is. 4 over 2 is just 2. So this is 9 to the second. But I even know what 9 to the second is. 9 to the second is just 81. So we could take a complicated looking expression and actually make it into a very simple answer, because the root and the exponent simply reduce on each other, and we get a very simplified answer. And the last one here is if you have negative in there, it still works with negatives. So the 10th root of 16 to the negative 8, we just write that as an exponent first. This is 16 to the negative 8 over 10. Well, negative 8 over 10 can be reduced, right? This is 16. If I divide the top and bottom by 2, I get to the negative 4 over 5. I really don't want a negative exponent in my final answer, as we said in the last video, so I'm going to write this as 1 over 16 to the 4/5. Or we could undo this, and we could write our answer another way. We could say it's 1 over the 5th root of 16 to the 4th power. That could be another way we write it. We could split it back into a root and exponent. So all of this, and this, all mean the same thing. They're different ways of writing the same expression. The one on the bottom, or rather the two on the bottom, are the simplified forms of the expression. They are the most reduced numbers you can get. And of course, we learned in the last video that we can do some funny things with 16 in this case, that we can split it into 4 to the second or 2 to the whatever, but I'm not going to bother with that here. I just want to mainly focus on the powers of roots and exponents. So once again, any root can be changed into an exponent by simply making it into a fraction and then working with it as if it was just a normal exponent. So you can multiply fractions, add fractions, divide fractions, but it's just going to be as an exponent rather than a normal number. Again, it's kind of a short video because there's not much to it. Just a quick little blurb about roots and exponents. Hope you enjoy the video. Have a good day.